Hello friends, welcome to the today's session. My name is Ravindra Sindhia. I'm currently working as a senior data scientist at with one of the top pharmaceutical companies in the world. And my journey in this field started with a strong foundation. So I completed my MTech in computer science from Indian Statistical Institute, Kolkata. And as many of you might be knowing that ISI is premier institute for mathematics and statistics in India. And over the last 5 years, I have applied these concepts across various industries. I worked at Z5 building good recommendation system for billion of users, and I also worked for Turing, contributing to cutting edge AI. And currently I'm working at pharmaceutical industry solving healthcare problems using data. So everything I teach you today is something I have actually used to solve real problems. So we are not just learning to pass an exam, but I'm going to teach you how an actual data scientist or ML scientist or ML engineer thinks. Okay, so before we dive into the lecture, I want to give you a roadmap of what we are going to cover today. So, I have structured this lecture into four key chapter. So the first chapter is the AI connection, basically to know the why we are studying this probability, why we are studying statistics, and we will look at the intuition behind ChatGPT and self-driving cars quickly, and uh, we will understand that probability is the language of AI. And in this chapter 2, we will see the descriptive statistic, the what. We will look how to summarize the data. We will look about the mean, median, mode. Okay. And in the chapter 3, we will cover the dispersion and the data visualization. And in the last chapter, which is the chapter 4, we will learn about the conditional probability, which is the most important concept in all AI. So today, friends, we are in almost everywhere in the industry. We uh, uh, we are not using the normal probability. Almost everywhere you will see we will use the conditional probability. Means there can be some systems where normal probability might be used, but whatever I have seen in my past experience, uh, most of the important concepts which are covered in AI uses conditional probability. So don't worry about the name. I will teach you about this concept. So it simply means how does new information change my opinion. Okay, so my promise to you is that we will keep the heavy math notation to minimum, and we will focus on the logic, the stories, the code, uh, and by the end of this lecture, you will basically understand that how a data scientist think, or how a machine learning engineer or data analyst thinks. So let's get started. So let me first tell you the AI connection, why we are here. So I'm sure most of you have studied probability and statistics in high school or college. Okay, but at that time, many of you might have felt why we are studying this. So where will this dice, coins, mean, median, mode will be used in real life? So, or you might have wondered how this is connected to AI or data science. So honestly, most students do not appreciate these topics early on. But today my goal is to change that mindset. So let's look at the AI connection. So many of you might have heard about this ChatGPT and Midjourney creating art and the Tesla cars driving themselves. So it feels like a magic, right? But let me tell you that all of them are some we are using the concept of probability and statistics. So let me tell you with example one, large language models. So so let me tell you. So ChatGPT writes a sentence. So it isn't thinking in the human sense, right? So it is actually calculating the conditional probability of next word. So let's say if you will go to ChatGPT and if you will ask that what is the color of sky. So let's say ChatGPT starts writing the skies, and let's say at this point ChatGPT stops and it thinks that what is the next word. So what do you think? How does it decide the next word? So friends, it doesn't think like a human. What it actually does it actually calculates the probability, conditional probability of the next word given the previous words. So internally, the model has the bucket of next possible words, and for example, blue, gray, green. Okay, and based on the training data, it assigns the probability. So uh, how it will do is like this: probability of blue given the sky is equal to 90%. So it will calculate the probability in this way, that given the word is this, the sky is, what is the probability of the blue. In the same way, it will calculate for gray and green, and then the model chooses the most probable continuation. So this is why it outputs the sky is blue. So the takeaway is the LLM models are stochastic, or they are probabilistic in nature. And now let me tell you the example two. So which is coming from computer vision, or you have heard about self-driving Tesla cars. Okay, now imagine a self-driving car on the road, and when a person crosses the road, so how does the car know that it is a human? So the answer is it doesn't know. It calculates a confidence score. So the model compares the cluster of pixels with thousands of images it was trained on, and then it outputs that okay, I'm 99.9% confident that this cluster of pixels represents a human. That 99.9% is the probability. So in ML world, we never deal with certainty, we always deal with likelihoods. Okay, and now let me tell you what this statistics and probability is, and how they work together uh, in this ML world. Okay, so statistics is the science of collecting, analyzing, summarizing, and presenting the data. It helps us understand what happened in the past. I will just uh, don't get confused with the definition. I will walk you through the example. So just be with me. And probability is the measure of likelihood that an event will occur in the future. So it quantifies the uncertainty. So the primary responsibility of the data scientist is to identify the different structures in the data. Okay, so as you can see in this picture, the both the probability and statistics are sitting on the data. So they both requires the data. And as I said in the definition, that statistics help us to understand what happened in the past, and probability uses this past data to uh, uh, know what will occur in the future, right? So in the way this statistics analyze this past data to help the probability predict the future inference. So both of the probability theory and statistics work together to provide the foundation of this data science, right? So for example, I can take some real life example. I work for Z5 in OTT platforms. So Z5 is same like Netflix. Many of you might have used. So there are a lot of movies. So let's say the scenario is you have a list of watch time for 1 million users. Okay, so what is the statistic might be the average watch time for some XYZ show is 30 minutes. So the role here is summarizing the massive data into a single useful number. And what will be the role of probability? So probability is a measure of likelihood that an event will occur in the future. So let's say let's take some weather example. Okay, so you look at the clouds and the temperature today, and the what is the probability here? So there is an 80% chance of rain tomorrow. So how it's doing all these things? So it is predicting the future based on the current uncertainty, right? So it is so as I told you that statistic helps analyzing the past data to help the probability predict the future or to make the inference, right? And you can understand it with one more real life example. So let's say you are working for Google, and you have a lot of customers who are getting the emails day by day, and let's say your job is to analyze 10,000 old emails, which is the past data, and you find that 95% of the emails are spam. So how you are doing it, right? So you have, your job is to basically find that which email is spam and which is not spam. So first what you will do, you will apply the statistics and you will find that okay, I have found that there is some kind of words like lottery or free or jackpot, and you found out that 95% of the emails contain the word lottery, jackpot, and all those things, and you mark that okay, these are the spams. Now what the probability will do here? So whenever a new email will arrive in the inbox with some, with this kind of words like lottery, jackpot, so the model calculate based on the statistics that there is a 95% probability that this new email is a spam, right? So in this way, this mail will be moved to the spam folder. So what it actually is doing is, what is the probability that this mail is spam, because it contains this kind of words. So that's how this statistics and probability work together. Now let me walk you through the definition of it. That probability is a measure of how likely an event is, and there are some golden rules which says that the probability of any event is always between 0 and 1. So what is an event? I will tell you just in some time with an example, but now just let's understand this golden rules first. That probability of any event will be always between 0 and 1. So that's I said here, and there is a summation rule that the sum of probability of all possible outcome is always going to be 1. That sum of p of e is will always be 1, right? Now let's talk about the experiment. Like let's say you are going to roll a die. So this is an experiment, so an action with uncertain result. So you are not certain that what result might be, right? Because the dice can have 6 faces. So so this is an action with uncertain outcome. So and there is a sample space which tells that the set of all possible outcomes. So when you are going to roll a die, so there can be 1, 2, 3, 4, 5, 6. So total 6 outcomes are possible. And as I told, the probability of event will always be between 0 and 1. So what is an event? So an event is a specific subset of outcomes we are interested in. So it is a subset of sample space that we are interested in. So let's say I have rolled a die and I asked a question, what is the probability of getting an even number on the die? So in how many possible way we can get an even number? It's just 2, 4 and 6, right? So this is the only possible thing. So this is called a favorable outcome. Okay, and the probability formula says that probability of E will be number of favorable outcome divided by total number of outcome. So if I will say you, so this is the total number of favorable outcome divided by total number of outcomes. So if I will say you that what is the probability of getting an even number on the die? So even number can come in the 3 way. Okay, so the favorable outcome is 3, and what is the total number of outcome? So total number of outcome is 6. So 3 by 6, which is nothing but 1 by 2. So that's how we will calculate the probability, right? Now let me walk you through the data and types of the data. So before statistics, we must understand the data. So there are two main types of data, so categorical and numerical. So when the data is divided into groups or categories, so there can be two more type inside it. So data can be nominal or it can be ordinal. So data can be divided into groups of categories. So for example, let's say in Z5 or in Netflix, you have seen the movies genre, right? So movies genre can be action or comedy. So there is no order inside this data. But let's say inside the ordinal data, there will be order. Like let's say in the Netflix, there is a subscription tier. So there can be free, premium, or ultra, right? So so these are the categories with a specific rank. Or let's say let me take you let me walk you through the example of Novartis. So let's say there is a person who is getting some pain. Okay, so the pain severity can be also be in the specific rank. So it can be low, medium, or low, medium, or high. But in the so this is the ordinal data, right? So if the data is a categorical data and it is a nominal, then there will be no order. So it will so as on the screen you can see the colors red, green, blue, right? So there is no order inside this data. And now let me tell you what is the numerical data. So whenever a data is represented by numbers, so it is called the numerical data. So numerical data can also be of the two types: discrete countable and continuous. So discrete countable means the whole numbers. So in Netflix sense, you can understand the number of times user paused a video, okay, or number of pills in a bottle. So this comes inside the discrete countable. And what is the continuous? So infinite possibilities can be there within a range. Okay, so let's take the example of temperature. So let's say the temperature is within this range, 15 degrees Celsius to 40 degrees Celsius. So there can be infinite values present between this range, right? Or there can be height, weight. So this all type of data are comes under continuous, right? So if there are infinite possibilities within a range, so that comes under continuous data. So now let's move towards the second chapter, which is the descriptive statistics. So descriptive statistics is where we summarize the data to understand what is happening. Okay, so if we want to get the meaningful insights from the data, so that's where descriptive statistics comes. So that can be done in three ways. So if you have heard about the central tendency, so this is a measure of central tendency or the center, and that can be measured in the three ways, like mean, median, and mode. So what is the mean? So it is the arithmetic average. So let's say you have a data set of 1 2 3 4 5. So the formula is summation of all these data points divided by total number of data points. So sum of x divided by n. So you will just sum all the data points inside the data set and you will divide by the total number of data points. So total number of data points are 5. So you will divide by 5. So the value will be 3. So 3 is the average. Okay, and in the Netflix sense, you can understand, like, let's say there are three type of users who watches a movie: user A, user B, user C. So they all watch the movie for 10 minutes. So what is the average? 10 plus 10 plus 10 divided by 3. So which is nothing but 10 only, right? So, and what is the median? So the median is the middle value when the data is sorted. So if the data if the number of data points in the data set is odd, then the median will always be the middle element. Like, you can sort this data and you can just pick the middle element, so that will give you the median. And if the data set is even, like let's say in this case there are 10 data points, so the middle two are 5 and 6. So what we will do in the case of even data set, we will just pick the two middle element and we will do the average of them. So average of the middle two element is 5 plus 6 divided by 2, which is 5.5. And what is the mod? So the mod is simply the most frequent value in the data set. So that the value that appears most often. So let me take you uh, uh, through the example of Netflix. So let's say in the Netflix, some users are watching the movie and they all rated a movie. Like let's say there are 5 users and they rated a movie like this: 5 star, 5 star, 1 star, 5 star, 2 star. So what is the most frequent value in this data set? That is 5, right? Because this is appearing 3 times more than any other value, right? So the mod is 5 here. So I hope you got the idea. So mean is the arithmetic average. That's where you have to do the summation of all the data points divided by total number of data points. And the median is the middle value when the data is sorted either in ascending or descending order, and the mode is the most frequent value. So now let me tell you like why we are studying all this concept. So what is the motivation? So let me now tell you the Z5 scenario only. So you can so whenever I'm saying Z5, so you can compare it with the Netflix scenario. So we have million of users who are watching the movies day by day, or who are watching the popular shows on our platform. So let's say my boss comes to me and he asks me that, Ravindra, please tell me which is the most popular show so we can release the next session. So let me give the attempt first by giving the mean. Okay, so let's say I have the data of the users for the watch time, and I have the watch time in the minutes. So let's say this is the data set and this is the watch time in minutes. So 10, 20, 30, 40, 50. So these are the 5 users who are watching a show, very famous show, Friends. So what is the formula? So this is summation of all divided by total number of data points, so which is nothing but 30 minutes. So the interpretation is that on average a user watches the show for the 30 minutes. But what do you think? What problem can a mean lead to? So let's say if there is a bot joins and he watches the show for the 10,000 minutes. Now if I will do the summation, if I will divide by the 6, because now there are 6 data points, so the mean will go to 1691 minutes. So it's saying that on average a user is watching for 28 hours a day, which is impossible, right? So the conclusion is that mean is not robust. So it breaks whenever there is an outlier exist. So I can't just go to my boss and say that, okay, average user watches for 20 hours a day. That is impossible, right? So the math is lying to us. So that's where the attempt 2 comes. So that's where we use the median. So median is the savior of for us. So let's see how. So as I said that in step 1 we will sort the data, right? So let's say we sorted the data and we will find the middle one. So what is the middle one value? So the data set is, so number of data points in this data set is even, right? So we will take the two middle values and we will find the average of those values. So average of 30 and 40 is 35 minutes. So the truth is, even with the bot, the median is 35, which is close to the real users, right? Because earlier we got that okay, users are somewhere watching the shows on an average around 30 minutes, so which is close to that. So actually you can see here like the median is giving us the truth value. So the conclusion is the use the median for watch time and salaries, employee salaries. So this is the real industry example that I have seen when I was working for Z5. And now you can see like the conclusion is the median we are using for the watch time. And you have also seen that how the mean is not robust towards the outlier. Now let's see the third thing, which is the third chapter, is the measure of dispersion. That why like as we have calculated already the mean, median, mode, so why mean is not enough, why we are going towards this measure of dispersion. So let's first talk about the range. Okay, so the range is simply the difference between the highest and lowest value in the data set. So it will give you the boundaries of the data. So the formula is max minus min. So max minus mean is the formula. And what is the variance in standard deviation? So just be with me. I will show you each of this concept using the example. Okay. So why we use this measure of dispersion? So you have likely heard the variance and standard deviation, right? So dispersion tells us the spread of the data. Okay, so the question is like, why do we need standard deviation if we already have the mean? Okay, so because we cannot trust the mean alone. Okay, so dispersion tells us how risky or spread out our data is. So I will just tell you all these things with the example. So just be with me. So let me just first tell you the definitions. So the definition of variance is the average of the squared differences from the mean. Okay, so it measures how far a set of number is spread out from their average value. And standard deviation is the square root of the variance. So it try to brings the number back to the original units of the data. So it tells you on average how far your data point is from the mean, and the formula for both the mean variance and standard deviation is written onto the screen. So as you can see, as said that how far a set of number is spread out from the average value. So how we are calculating it, summation of x minus mu whole square divided by total number of data points, and standard deviation is just the square root of the variance. So why we are doing the squares, why we are doing the square root, I will tell you in just some time. So just be with me. So let's see the risk, the measure of dispersion. Okay, so let's understand this thing with the example. So let's say there are two shows on Netflix. Okay, so one is spiking up, and so one is like a flat show, like where all of the users are watching with a consistent time, and one of the show is spiking up and down, but both of the shows have same mean. Okay, so I will tell you like why this standard deviation variance we are using. So why this mean is not enough, or why this central tendency is not even enough for us. So let's see this show A. So show A, everyone. So let's say every user is watching the show A. So everyone is watching with 50, 50, 50, 50, 50 minutes. So everyone is happy, like, right? It seems like that. And in show B, if you will see, the user one is watching for 0 minutes. User two is also watching for 0 minutes. But if you will see, the user four and fifth, they are watching for 100 minutes. So either people are loving the show or they are hating the show. But if you will see, for both of the shows, the mean is same. Mean is 50 for both of the show. So just by looking at the data, we can't say that okay, both of the shows are good, because uh, the Netflix team might be thinking that okay, if the show is very popular and if the user are watching them with consistency, then we will just release the new season of that show. Okay, so they have to know which show is very popular or which show is very good among the people. So so if you will see, the danger here is, so in show A everyone watch the 50 minutes, so no one will cancel the subscription, right? Because everyone is liking the show. But in show B, if you will see, there are some angry customers and some are very good customers who are liking the show. So some customers who are not watching the show might leave our platform, right? There is a chance of churning, so they might leave our platform. So we can't build a business on 50% of the people who are hating our product, right? So now see, now I will just show you the calculation, and I will tell you like how calculating this variance will help us to give the actual estimate that which show is good and on which show we should focus to release the next season. Okay, so if you will see the formula of variance, I have written that x minus mu whole square divided by n. So first you have to calculate the x minus mu, right? So if you will do the x minus mu, so mean is 50, so these values will come. So these all are calculated for show B, because show A, if you will calculate this x minus mu, you will get that everyone will cancel out each other and you will get zero value, because 50 minus 50 plus 50 minus 50 whole square, so everyone will cancel out each other and you will get zero value, right? So that's why we are I'm just showing the calculation for show B. So if you will see, the calculation for show B is like this. Now let me tell you like why we are using the squares. Okay, so we can simply add the deviation, right? Like summation of x minus mu divided by n. This thing also we can do, but why we are squaring these things? Because if you will just sum this all these things, they all will cancel out each other and you will get the zero variance, which is not what we wanted, right? So by squaring we are ensuring that the negative values will not cancel out each other, because if you will see here, the minus 15 plus 50 will cancel out each other. So that's why we are squaring this deviation, and after squaring we are dividing it with the total number of data points. So this is giving us the variance as 2000 values. But if you will see this 2000 number, uh, it's very high, right? And if you will see our data points, so they are not in that range. So they are somewhere in the range of 0 to 100. So that's why we have. And also if you will see, so here the we are doing the squaring. Okay, so all these things or this variance will give us the minute square. The unit of this variance will be 2000 min square, which is not something we want, because we want the variance also we want the deviation also in the same unit like our data set is, like in the minutes. So that's why we are calculating the square root of the variance. So the unit in square minutes is not making sense. So the solution is we are doing the square root, and now we will get that okay, 44.7 minutes we got. So it is giving us the interpretation that on an average it is deviating from the mean by 44.7 minutes, in right, plus or minus 44.7 minutes. So on show B, a user watch time fluctuates by plus or minus 45 for 5 minutes, but if you will show a standard deviation, it's coming at 0 minutes. So what's the conclusion here? So conclusion here is that show A is safer to release, right? So all of this insights we can get using this measure of dispersion. So I hope now you got the idea that why we are using this measure of dispersion and why we are calculating this variance and standard deviation. Because we can know that okay, which data is highly volatile, and in machine learning that highly volatile data or noisy data often leads to bad prediction. So we want a data set which is showing some consistency. So in the business context of Netflix, you can understand that there is a churn risk which is associated with this problem, right? So if there are two shows which were showing the same average watch time of 50 minutes, but just by seeing their uh, mean value, we can't say that okay, both shows are good, because with show B there is a churn risk and they might cancel the subscription. So the high standard deviation is giving us high business risk. Okay, so we have to so if I will give these insights to business teams, so they can look after the show B also, and they can find out that okay, how they can make that show be also good, so that the people can watch that show be with consistency, right? So why do we square the differences that I already told you? Now the third topic is data visualization. So it is the eye test. So visualization is very critical. So if you will master this visualization technique, you will master many things in AI. So let's talk about the histogram. Okay, so histogram is for visualizing the spread. Okay, so imagine we have users. Okay, so we have already talked about users who are watching the shows on our Netflix platform. So let's say there are some users who are watching the shows for 0 to 10 minutes, some are watching for 10 to 20, some are watching for 50 plus minutes. So we have so I have created some three buckets of hated, liked and loved it. And I am putting all the users inside that bucket. That okay, in the bucket one there will be users who are watching the show for 0 to 10 minutes. In bucket two, the users will there will be users who are watching the show for 10 to 50 minutes. And in bucket three there will be the users who are watching for 50 plus minutes. So we take every users and throwing them into the bucket. So we will see then this kind of distribution. So it is somewhere representing the normal distribution. So in the future lectures you will understand what is the normal distribution. But now you can see that just by seeing the data, without seeing even the number, just by seeing the data I can know that okay, the most people watch time is between 20 to 30 and 30 to 40. So it's somewhere coming on an average around 30 minutes, right? So that's why this data visualization is very good for us, because the graph tells us stories. And as a data scientist, your job is to uh, see how the data is giving us the insights. And the best way to get that is to always go with the plotting techniques, like I have shown you the histogram now. Okay, and you can see also the second graph. So here if you will see, there are two graphs. So one is both are for the user watch time. So in one, the user watch time is like, you can see the data is very spreaded out. So and in the one of the show which shown, the graph is shown in the blue, the watch time is between 20 to 40 minutes. So just by the seeing the data you can know that okay, the standard deviation of this plot is very low, because the spread itself is very low. And I already told you that this variance and standard deviation tells us that what is the spread in the data. So if the spread of the data is very low, means it's giving us the low standard deviation. And the spread of the data is very high, then the standard deviation is very high. So just by seeing the data you can know that okay, which data is showing us the consistency and which is data is not showing us the consistency. So even just without the numbers you can know about the data. And like what they are trying to tell to you. Okay, so if the graph is wide, so standard deviation is high. So immediately that tells me that the show is very risky, because the standard deviation is high. So people either like it or hate it. But if the graph is narrow, like shown in the blue bars, so the standard deviation is low and the user behavior is consistent. Now let me tell you the third thing, which is nothing but a scatter plot. So scatter plot is often used for visualizing the relationship. Okay, so the bar plot was showing just the what is the variation in the y axis. But here you will understand that how uh, if I am changing the x axis, then how the y axis is changing. Okay, so sometimes these bar charts aren't enough to understand the relationship between the two variables. Like now let me tell you with the example. Let's say I am showing the ads to people who are coming on my OTT platform. So what do you think, that user watch time will increase or decrease? They will hate it, right? If you will show them more ads, okay, if you will show them more advertisement on your show, then the watch time, so generally it I have seen that the watch time of the users will go down. So that is the so that's what shown in this plot. So each blue dot here is showing us an individual user. Okay, and this plot is created using the two variables, number of ads shown and watch time in minutes. So if you will see, so in general if you will increase the number of ads, then users are going to head that show and the watch time is going to be less. Okay, so this shows us the negative correlation. So correlation and all that topic are some separate, but now just to show you that what this graph is helping us. So this is helping us to visualize the relationship between the two variables. Okay, so if there is no correlation, so you can just understand like this, that if the straight line is going in the negative direction, or like if you are increasing the value on the x-axis, the y axis value is going to down, then it is showing us the negative correlation. And if there is no relationship, like you are not getting any relationship using this data, then it's showing us that there is no relationship. Like let's take the example of user shoe size, and we are comparing it with the watch time. So there is no relationship between these two variable, right? So there is no correlation. But if the dots are going up, like let's say if more episodes are released, then more renewals are coming, right? Because subscription uh, rate will generally increase just when more number of episodes are going to release. So let's say some show is very popular on Netflix, and if they are going to release the more and more episodes, so the subscription rates of user will also go on increase. So that shows us the positive correlation. Okay, so this was something about the data visualization. All right, friends, that brings us to the end of this session. I know this was a long lecture, but we covered some massive ground today. So let's quickly recap what we learned. So we started with why, how ChatGPT and self-driving cars run on the probability, not magic. And we saw how the mean can lie to us and how the median can be our savior. We learned that mean isn't enough. We need standard deviation. And then in the end we saw how to visualize this. We looked at histograms and the scatter plots to find the relationship, like how showing too many ads kills our watch time, that negative correlation. And in the next lecture we will open the Google Colab, and we will plot the graphs and all the concepts that we covered in this lecture. And most importantly, we will deep dive into the conditional probability, the math that actually powers AI models like Neobase. So if you stayed till the end, I really appreciate your patience. And data science is a marathon, not a sprint. And you just finished the first leg. So I need a small favor from you guys. Please let me know in the comments. Did you like this industry first approach? Do you want me to continue the series with more real world examples? And if you found value in this session, please like and share it with your friends who are starting their data science journey. Thank you so much for watching. See you in the next session.